Let's start.
Okay, sir. So good morning, everyone. Again, so I hope you have tried all the problems. Do let me know if you have any confusion in between. So this is the first problem. In first problem, the potential shape is given to us towards this left side of the origin. It's infinity. In between 0 to x equal to a, it's minus v0, and from a to infinity, it's 0. And also the energy of the particle is given. It says that it's between 0 to minus v0, so it's between this position to this position. Okay, the total energy. So let us write our energy to be equal to some, it's definitely negative, so we can write it like this, minus of modulus of E. Okay, now we are supposed to write the wave functions everywhere. In this region it's psi1, and here it's psi2. Okay, so the Schrodinger equation is minus h cross by twice m d2 psi by dx square plus v psi equal to E psi. So if I write in the region 1, 0 to x to a, 0 to inside this 0 to a, then it will become minus h cross square by twice m d2 psi 1 by dx square minus v0 psi is equal to minus of modulus of E of psi. Correct? Psi 1, 1. Now we have to solve this. We make it like this, d2 psi by dx square. This will be equal to 2m by h cross square. Then here it will become E plus v0. This thing we take it like this, and this will become this. It's correct. So if we simplify it even further, it will become 2m by h cross square v0 minus mod of E psi 1. So let us write k1 to be equal to k1 square to be equal to 2m v0 by h cross square. And we are just writing all these terms in terms of k1 and k2. So let us write this k0 square to be equal to 2m modulus of E by h cross square. Did I write this line correctly? Minus h cross square by twice m d2 psi by dx square minus v0 psi
Earlier,
1.
there should be a negative sign in the last step, like minus 2m h cross
Yes,
square.
minus 2m here. 2m by h cross square minus E plus v0. Yeah, this is correct. So now we can write it to be equal to something like k1 square minus k0 square psi 1. Okay. So let's suppose this is equal to minus k2 square psi 1. Then we can solve this, right? This psi 1 of x can be written as a sine k2x plus b cos k2x. Okay. Now because here at this point, and in this side the wave function is 0. If you put the boundary condition, so here psi 1 at 0 should be equal to 0, right? That means this b should be equal to 0. Are you guys with me?
Yes, sir, yes.
Yes, yeah.
Yes. So finally our psi 1 x should be equal to a sine k2 x. Now if we go to this region, x greater than a region, so here we will similarly get this equation, but in place of in here v0 will not be there, so our psi d2 psi 2x by dx square will come out to be equal to k0 square psi 2. Okay, because v0 will not be there, so here it will simply become 2m modulus of e by h cross square psi 2. So now this is a type, this is d2 psi by dx square is equal to omega square psi type of equation. So here our equation will become exponential. So c e to the power k0x plus d e to the power minus k0x. Now again, if you see at x tends to infinity, this psi x will blow up if c is not equal to 0. So that's why c should be equal to 0, so that psi 2 is finite. So finally, our psi 2 x will become d e to the power minus k0x. Okay. Now let us put the boundary conditions for x equal to a. So at x equal to a, our psi should be continuous. So a sine k2a should be equal to d e to the power minus k0a. Everyone agrees?
Yes, dear.
Okay. Again, now it should also be differentiable, right? At this point. So it will
Yes, yes.
become a k2 cos k2a will become minus d k0 e to the power minus k0a. We just differentiate this, so it will become d minus k0 e to the power minus k0x, and we are putting x equal to a. Now just divide these two equation, we will get cot k2a is equal to minus k0, and also here k2. Yeah. So this is the equation. If we now simplify this, this is basically cos k2a by sin k2a equal to k0 minus k0 by k2. So let me find k2 sin k2a. So it will become 1 by sin k2a equal to, I am taking square from this and adding. So it will become k0 square plus k2 square by k2. Okay. So here from here you will get sin k2a to be equal to k2 by k0 square plus k1 square. Okay. So now if you simplify this k0 square plus, here it was k2, k0 square plus k2 square, it will become k2 by k1. Here one root over will be there, here one root over will be there. So this is just a simplification. So finally what we get is our k2 will follow a equation like this: sin k2 equal to k2 by k1, where our k1 is a constant. See here, our k1 is definitely a constant, but our k2 is a variable, right? Because k2 is having the energy term inside. So this equation you cannot solve directly. You just have to use analytical solution. So like you can solve it graphically also. You plot the sinusoidal function. You know your k1. You may be knowing this k2 by k1 equation. So number of solutions you can get from here. Exact solution you have to do it analytically.
Bhaiya, how you did last step? Actually, I didn't understand. After
Uh,
cos k2a by sin k2a, after that, how you just squared up upper one?
oh yeah, just I am just writing root of cos k2a root over of 1 minus sin k2a. Basically what I am doing is, in place of cos k2a, I am just writing this square plus this square here, root over of this square plus this square. So same way I have to write it here also, right? This square plus this square root over here. No, you just simplify. You find
Okay.
cot k2a in terms of cosec square, then you convert it to sine. You will get.
Bhaiya, can I
Yeah.
ask something?
Hmm.
Yeah, for this equation, the like d2 psi 1 by dx2 equal to minus k2 square by psi 1. I mean, when do we take this a sin k2x plus b k cos k2x solution? When do we take the solution a to the power e minus k2x plus b to the power I k2x?
Okay. Yeah. This is very good question. So whenever you write a equation like this, d2x by dx square is equal to some positive number times of x. Okay, there is a negative sign here.
Yes,
So
yes,
you know definitely that this is a positive thing. So if you get a this is SHM equation, right?
yes.
So here you will write a sine k2x plus b cos k2x. But
Okay.
if you have a plus sign here, this is not a SHM equation, right?
Yes, yes.
So in this case, you write like this.
No, no, that I understood. Like
Hmm.
in the step potential only, we were getting the this same equation for the first region, right? When the potential, we haven't reached the potential step, but there we take the solution to be a to the power e minus ikx plus b to the power plus ikx for the same SHM equation only.
Oh, okay, okay. Let me tell you this. So if you have an SHM equation, then you can either write your equation to be equal to a sine kx plus b cos kx, or you can also write c e to the power ikx plus d e to the power minus ikx. Okay,
Yeah,
these
that
are
only. I am
equivalent.
asking when do we have to choose, like when should
No,
we choose the sine one and when should we choose the other one?
no, they are identical equations. You if you convert this na e to the power ikx to sine and cos, what it will come? Sine kx plus cos kx by 2 I sine e to
Yeah,
the
yeah.
power I k. Okay, then this numbers will these coefficients will be basically changing. They are identical. Whatever you choose, you will get the same result.
Okay, okay.
Okay, but this should be SHM equation. Then only you can use, right?
Yeah,
It
that
should
I
be
know.
clear that this is a minus of some positive number into x.
Yeah, yeah. Thank you.
Then only you can write. If this is a plus of positive number into x, you cannot write like
Mm,
this. You have to
mm,
definitely write like this.
yeah. Okay, thank you.
Okay, the next question. So here, SHM simple harmonic oscillator in one dimension is given. Hamiltonian is given to us. At t equal to 0, the wave function is also given to us. We have to find what is the wave function at any time t for t greater than 0. So do you guys know these are stationary states, right? Psi 0x and psi 2x are stationary states. Do you know
Yes,
that?
yes,
Yes,
yes.
we are.
Okay. And if some stationary states is there, it will always evolve as per this equation. Psi 0 at t equal to 0, e to the power minus I e energy of that stationary state E0 t by h cross. Okay. So this is how a stationary states evolve with time.
Sir, I had a doubt.
Yes.
So in the first question, like, so they've asked us to write the wave function. So when they ask us to write a wave function, you don't need to normalize it.
Sir, Perumal sir, you have anything to say?
Sorry?
Do they need to normalize the wave function whenever they are asked?
Like here, they have told us write the wave function. So can you just write a sine k k2x and c e raised to what d e raised to minus k naught a, or do we have to normalize the a and c?
No, unless asked, why do you want to do that?
Okay, sir. No, because the question says write the wave function, so we can just write with like non-normalized wave function, right?
Yeah, yeah, this is also a wave function, right?
Yeah, yeah, okay, sir.
Unless asked to find out all the, the constant, you don't need to do that.
Okay, sir.
But in the question, if you end semester, if you have question, but do not hesitate to raise the query to your proctor, because sometime we will also that I note down this point. So when we finalize it, I will raise this point that if anything is given, do we need to solve it? I'll take a note of this particular point, and I'll put it up to the both the instructors and see if there is can be something to be done. So basically, what your question is that should we find the constants or just only write the wave function with the unknown constants, right?
Yes, sir.
Write final result without finding actual values of the constants. Correct? My understanding is correct? Is my
Yes,
Yes,
sir.
sir.
understanding? Yeah, fine. I noted down the point. I will raise it when we discuss. Right? Good that you raised that doubt.
Okay. So for any stationary state, psi n x, the psi n xt will become psi n x at t equal to 0 e to the power I e n t by h cross. Okay. So because this is simple harmonic oscillator, you know what is En. What is En, by the way?
N plus half h omega.
N
H.
plus
N
half
plus half h.
h plus omega. Correct. Yeah. So because now you know how the stationary states evolve with time and how the energy form looks like. So you can simply find what is psi x at t. It will become this constant 1 by 3 psi 0 x e to the power I e0 t by h cross plus 2 by 3 psi 2 x e to the power I e2 t by h cross. That's it. Now you know E0. E0 is half h cross omega. Then E2, here you know need use E2. So it will become 2 plus 1 by 2, 5 by 2 h cross omega. You just substitute here. That's it. In place of E0, you will write h cross omega by 2. In place of E2, you will write 5 h cross omega by 2. So that will be the answer. Okay. Everyone agrees?
Yes, yes, sir, yes.
Okay. Now we are supposed to find what is the average value of energy for this state. So average value of energy for this state is either you solve it start like this, psi e psi, then you do the integral minus infinity to infinity psi star h psi dx. If you try it like this, you will get the same result. And because it is a stationary state, you know what is the energy corresponding to this state. What is the energy corresponding to this state? You can also find it like this. Average energy will be equal to probability of finding the particle in this state. What is the probability of finding the particle in psi 0 state, by the way?
1 by 3.
Amplitude square.
1.3.
Amplitude square. Yes. So 1 by 3 amplitude square. This is the probability. And what is the energy in this state? Psi
Sir,
0.
half h cross omega.
Yeah, it will be E0, right? Yeah. Then plus what is the probability of finding the particle in this psi 2x state in
2 by 3.
2 by 3 amplitude square, and what is the energy corresponding to this state is E2. So this will be the average energy. So you can now substitute E0 and E2. This will be the average energy. Okay, you just try like this. You should get the same result. Okay. Can I go ahead to next problem?
Yes,
Any
sir.
Yes,
doubt?
sir.
No, yeah.
Next is the find the Heisenberg equation of motion for position and momentum operator and solve them for 1D simple harmonic oscillator. Okay. So first we have to write the Heisenberg equation. So Heisenberg equation is dt t of any parameter xt is equal to, so IH cross here, IH cross gdt of xt is equal to commutator of xt comma Hamiltonian. This is the Heisenberg equation for x. Now you know what is ht. ht is equal to p square by twice m plus half m omega square x square for SHM. Now you have to, by the way, do you guys know what is commutator?
Yes, if A comma B has commutator A, B minus B.
AB minus B.
Do you know this formula? A comma B C is equal to, if, okay, do you
Yeah,
know this formula?
B A comma C
Yes,
minus A comma B
B
C.
A comma C minus A comma B C. Whatever is in the front, it will, if you take it out, it will come in the front. Whatever is Oh, here it will be plus. Whatever is at the back side, if you take it out, it will go to the back. Okay. So we will be using this formula, and also we will be using what is commutator of x comma p. What is commutator of x comma p?
Iota H cross.
I h cross, yes. And what is commutator of p comma x?
Minus IH cross.
Minus I h.
Negative.
Correct, yes. So we will be using that. Oh, by the way, what is this? What is x comma x?
0.
0.
0. Same way p comma p will be 0. Okay, good. So we want to find what is commutator. Somebody wanted to ask something?
Yes, Bhaiya, in A comma B, it is BC or B comma C, actually.
A comma b into c.
B into C, okay.
Yes. If two parameters, like you will see here in the next step, we have to find x comma p square by twice m plus half m omega square x square. Okay, we want to find the commutator of this. If something is plus, you can separate the commutators. X comma p square by twice m plus x comma half m omega square x square. If some constant is there, you can take it out. 1 by twice m x comma p square plus 1 by 2 m omega square x comma x square. Now this is same, right? X comma x square. If you write it like this, x comma x into x, you will get x commutator of x comma x plus x comma x x. So it will become 0, right?
Yes, Bhaiya.
Yes,
This
Bhaiya.
will become 0. Now here you need to use this formula, a comma bc formula. So from here, because this is same quantity, even if you write this formula slightly some with some mistake, then also it's fine. But if they are different, then you have to correctly write this formula. Otherwise, this will give wrong result. So here we will write p square to be equal to p into p. So one p will come out, x comma p. Which bracket I will use? Okay, like this. So one will be x comma p p. Okay. So x comma p, we know it is IH cross. So IH cross, we can take it out. 2 times IH cross will come out. IH cross by m into p. This is correct? Everyone understood this?
Yes, yes, yes.
So now if we write the Heisenberg equation, IH cross dxt by dt, it will come dx by dt to be equal to p by m. Correct? IH cross will get cancelled. Only p by m will remain. Similarly, if you write it for dp by dt, you will get, let me find what you will get. You will get minus m omega square x. Okay, you do it similar way. P comma p square by twice m, it will give 0. P comma half m omega x square, it will give this quantity. Now you take the second, you take two times of derivative, d2x by dt square. It will give dp by dm. You substitute from here, you will get minus omega square x. Okay, now you know, you get this equation, so you can solve it. You will get xt to be equal to a sine omega t plus b cos omega t. Okay, now at t equal to 0, the particle will be at x0. So at t equal to 0, we can get the constants now. A we do not know, but b we will get. From here we get the b. Okay, now to get p, how to get p? P is basically dx by dt into m. So it will become m a omega cos omega t plus m b minus m b omega sin omega t. Are you guys with me?
Yes,
Yes.
Bhaiya.
Same way, now you do at t equal to 0, the momentum is p0. So from here you will get, you already know what is b. It is x0. Okay, this will become anyway 0. So it will become m a omega. So from here you get a. A will be equal to p0 by m omega. Now you know what is a and b. You just substitute here. You will get the equation for x and t. X and p. Okay. Finally, you have to substitute this a and b in terms of x0 and p0. So any doubt?
No.
No. Okay. Let me go to the next problem then. Next problem is an electron exists in 1D and is confined to the right half space where it experiences a potential of the form this. So electron is confined in this region with potential is also given to us. This is like a image potential of an electron outside perfect conductor. So for this you will get in PH102. So image potential, it's like this. Okay, if you have a conductor and you are putting a point charge at this at a distance x, and this is a conductor, grounded conductor, suppose. So you want to find a potential of this configuration. What you can do is it is equivalent to finding this configuration is equivalent to this. If you put the charge at x and if you put the image charge at x distance away and with a negative sign of this, if you this conductor you can replace it with this configuration. This is called image value problem. Image value problem. You will get this in PH102. If you now see this now, what is the force experienced by this charge due to this conductor? It will become simply equal to F is equal to k q squared by 4 pi epsilon naught. Distance is 2x squared. This is the force experience due to this conductor on this charge.
Bhaiya, is this only for infinite condition or if
Yeah,
for some?
it's for infinite condition. Yes, this is an infinitely long conductor.
Okay.
Bhaiya,
So
why
you
is
will
there
get,
not pi epsilon not factor in question?
yeah. Here, if you take, this is SI unit. So let me, in place, okay. This is SI unit. If you put it in CGS unit, you write 4 pi epsilon to be equal to 1.
Oh, okay.
So this is not important to solve this problem. You just get this information that you will learn something new in PH102 in electrostatics. Okay. Next, making an answers for the wave function to be the form of this, we have to find the ground state energy. You know what is wave function, you know what is potential, you can simply find the ground state energy. So let us do it. So here in this, what we have to do is minus, we will write the Schrodinger equation again, minus h cross square by twice m d2 psi by dx square plus v psi is equal to e psi. Now we need d2 psi by dx square. So let us find the d2 psi by dx square. Psi prime x will become a 1 minus alpha x e to the power minus alpha x. Correct?
Yes, Bhaiya.
Double prime a, it will become minus alpha plus 1 minus alpha x, 1 minus alpha x into minus alpha. Oh my god. So it will become minus 2 alpha plus alpha square x e to the power minus alpha x. Correct?
Yes, yes.
So if we take this minus a alpha, just do let me know if I am wrong or if I did any mistake. Is this correct or not? There is a minus, I think.
Yes, Bhaiya.
Correct, right? Okay. Let's go ahead now. So it will become minus h cross square by 2m. So this will become plus a alpha 2 minus alpha x e to the power minus alpha x plus, okay, minus e square by 4x a x e to the power minus alpha x is equal to e a x e to the power minus alpha x. a a a will get cancelled. This x will get cancelled. E to the power minus alpha x will get cancelled. So finally we get it's equal to h cross square by twice m. H cross square alpha by m minus h cross square alpha square x by twice m minus e square is equal to e times of x. Is
E
this
square by
correct?
4 भैया.
E
Or
square
E
by
square by
4. Yes. Now this equation should be holding for any x, right? So that's why for even for x equal to 0 it should hold. So that's why h cross square alpha by m should be equal to e square by 4 and h cross square alpha square by twice m should be equal to e. Okay. So from here you get your alpha to be equal to m e square by 4 h cross square. And from here, if you substitute this alpha inside, you will get e to be equal to e with a negative sign. Yeah. E to be equal to h cross
Yeah,
square.
negative.
If you substitute alpha, it will become m square e to the power 4 by 16 h cross to the power 4. So here it will become h cross square m e to the power 4 by 32 h cross square. Okay. So you get that your alpha is equal to this. By the way, what is this value? M e square by h cross square. Bose radius, okay. So Bose radius is given by a0 is equal to h cross square by m e square. So your alpha is actually 4 times of 1 by 4 a0. Now, if you write the Rydberg energy is equal to m e to the power 4 by 2 h cross square. So this energy, ground state energy, you get it to be equal to Rydberg minus of Rydberg energy by 16. So 16 times lower than the Rydberg energy, and this is it. You are supposed to find a ground state energy, and we get that our ground state energy is actually 16 times lower than Rydberg energy.
Bhaiya, do we consider ground state to be at x is equals to 0?
Yes, we are considering ground state
So
x equal to
how
0.
can we say that E equals to h square alpha square by 2m when x equals to 0? Because in that case, it is not necessary.
Sorry.
So, when x equals to 0, it is not necessary that E is equals to minus h square alpha square by 2m. That equality can simply be holded by x equals to 0. So there is a condition now that it may or may not be equal to that.
No. Sorry. So basically, this equation will hold for any x, right?
Uh, yes, I am saying that since h square alpha by m and e square by 4 is eliminated.
Actually, the thing is, the particle should not be necessarily at x equal to 0. It can be anywhere, right, in this region. Wherever it is, the energy of this particle, you get it to be equal to this much.
Yes, I am saying I am just asking that since ground state is at x equals to 0.
No, it's not correct actually. Yeah, it's not correct. You cannot say that ground state is at x equal to 0.
Okay.
Yeah. You still have the confusion?
So what is the ground state here exactly? Because we are getting only one value of energy, right? There aren't multiple
Yeah, there
values
is
as
no
well.
quantum number deciding ground state or quantum states any.
I think that part is included in this wave function only. I am also not very sure, but because you are directly given that the particle wherever it is having this wave function, that means this wave function will also have the information of the state, right? Like wherever we write the stationary states, if we know that this is psi 0 x, we know that this is in the ground state. Maybe
Yeah,
this wave function already included that fact. I'm also not sure about that. Yeah.
okay.
Yeah. Okay. Next, to find the expectation value of x in the ground state. So how to find the expectation value? Expectation value of x, we know it is equal to minus infinity to infinity psi star x, x, psi x, dx. And you know the wave function. So finally, and it is going from 0 to infinity, because x less than 0, we do not have the wave function. 0 to infinity psi star x square x cube and e to the power minus 2 alpha x dx. Okay, this is what the you have to find this integral now. By the way, to get a, we need to get a, right? Before solve this, how to get this a?
Normalization.
Normalization. So we will normalize this 0 to infinity a square x square e to the power minus 2 alpha x, this equal to 1, and this is a gamma integral, right?
Yeah,
Last time we got this x 0 to infinity x to the power, how did we write x to the power?
n.
N e to the power minus alpha x dx is equal to gamma of
N plus 1 by alpha.
n plus 1 by alpha to the power n plus 1, correct?
Yes, yes.
So this integral we will use. So you substitute here, we will get e square. This will come out to be gamma of 3 divided by 2 alpha to the power 3. Okay. Gamma of 3 is actually 2 factorial. So it will become 2 a square 2 by 2 alpha whole cube. So from here you will get a. Same way you put this here, after you get a, you put it here, this integral will become a square gamma of 4 divided by 2 alpha to the power 4. Gamma of 4 again is 3 factorial. When you substitute a value from here to here, you will get your expectation value to be equal to, you will get 3 by 2 alpha. Okay. Now you already know your alpha is equal to 1 by 4 is 0. So that's why it will become 6 times of Gauss radius. Okay. So this is simple substitution problem. You just need to know what is expectation value written as. Then you have to know what is the gamma integral. Then you just solve it. Any doubt?
No, sir.
Okay, the last problem. So here a particle in 2D infinite square well is given. So in x and y direction, we have the 2D. The energy of the particle is also given to us. We have to find what is the degree of degeneracy in this energy level and what are the corresponding eigenstates. Okay. So if it is in 1D, what is the wave function look like, by the way? 1D infinite potential well bounded from 0 to L. It will become 2 by L
Sin n pi L
sine n by
by Ln.
x by L.
Yeah.
Okay. And energy of this state is actually h cross square k square by twice m, and k is actually n pi by L. So n square pi square by n square. This is the energy of this state. Now, if it is in 2D, then we have to write psi nx ny x comma y will be equal to, this will come two times, one for corresponding to x, one corresponding to y. So it will become 2 by L sine n pi x by L sine nx here ny pi y by n. Okay, this will be the wave function if it is in 2D, and energy corresponding to it will become h cross square by twice m pi square by L square nx square by n square. Okay. Now we are given that our energy is this much. So if you compare it, your nx square plus ny square will come out to be equal to how much?
25.
No, this 2 is also there, no?
50.
50.
Oh, sorry, 50. 50.
Now, because it is 50, now we have to find the integer values of n for which this equation will solve. So give me some values, solution of this. What will be the
5,
solution?
5, 7, 1, 1, 7.
Correct. 5, 5, 7, 1, and 1, 7. Other than this, any other possible values?
No.
No. So that means the degree of degeneracy of this energy state is actually 3. Or we can have only 3 combination of nx and y to get this energy. And what will be the corresponding eigenstates? It will be, you just have to put n5. This will become, one will become psi 5, one another one will become psi 7, 1, and another one becomes 1, 7. You just have to write the equations. 2 by L sine 5 pi x by L sine 5 pi y by L 7 pi x by L 7 pi y 1 pi y by L, like that. Okay, so this will be the answer. Any doubt?
No, sir.
Okay, good. Next is, we are given a 2D harmonic oscillator where energy states are given nx plus ny plus 1 h cross omega. What is the degree of what is the degeneracy for any arbitrary quantum number n? And verify your result for energy equal to 4 h cross omega. Write down the corresponding eigenstates, and we don't need to normalize them. So if you write 1D harmonic oscillator, what is the corresponding energy values?
N plus half.
N
S,
plus
S,
half
H cross
h cross omega. Now if you have 2D, your En will become nx plus half h cross omega plus ny plus half h cross omega. So it will become nx plus ny plus, like this, right? Into the, so basically we are getting nx plus ny plus 1 h cross omega. Now, what are the different combination of C? Now we know nx and ny can be any number. Nx can go from 0 to n, right?
Yes.
Okay.
Yes, sir. Yes.
One value can be 0 comma n, 0 n. It will also give n plus 1 h cross. So ny can also be 0 to n. We have total n plus 1 number of combinations. In place of nx, we can have 1 plus 1 values. So degree of degeneracy will be n plus 1. That's why. If you do it for equal to 4h cross omega, it will be clear. 4h cross omega. So what will be the corresponding values for nx and ny? One will 0, 4, one will be 1, 3, 2, 2.
Sir, it
3,
will be from 3, sir. It is n plus 1, right? Nx plus ny plus 1 is there. It will be 3. I mean,
Oh, yes,
nx
yes,
plus
yes.
ny plus
1 is there. Yes, correct. Thanks. So it will become, let me write it. 1 was already there. So it will become E is equal to 4 h cross omega. So we will have 0, 3, 1, 2, 2, 1, and 3, 0. So we will get 4 values of nx and y, which will correspond to this energy state. So this 4h cross omega is basically 3, right? Here E3 is equal to 4h cross omega.
Yes, sir.
So we are getting 3 plus 1, n plus 1 fold of degeneracy. Now what are the eigenstates corresponding to this? It will be, if I write it for this, it will become h0 some alpha x into h3 alpha y e to the power minus alpha x square by 2 e to the power minus alpha y square by 2, corresponding to this. Now for this, what will be the change? Only in place of h0 we will have h1, in place of h3 we will have h2. Similarly for this and this, you will get all the eigenstates. What are these h caused, by the way?
Hermitian.
Hermite polynomial.
Hermite polynomial.
And what is this alpha inside this? M omega by 2h cross. So that's it. Any confusion?